we will begin our presentation. Welcome everyone to JADAK's webinar on simplifying RFID implementation with the RAIN communication interface and autonomous workflows. My name is Justina Valencia and I'm part of the marketing group at JADAK North America. On the line we have our presenter, Principal Systems Engineer, Dan Ratner. Today's agenda will consist of a quick introduction to JADAK and our sister company Novanta and a little bit about ThingMagic, which is our RFID product line. We'll then go into what is RCI and how do I benefit, the language of RCI, structure of RCI, using workflows, and then using RCI with our new products EL6e and Elara readers. We'll then go over some developer tools and conclude the presentation with a Q&A at the end. So, little background about JADAK. JADAK is a business unit of Novanta, and we specialize in machine vision, RFID, barcode, printing, and computing products, providing both off-the-shelf and optimized product solutions for medical device manufacturers. Since being founded in 2000 in Syracuse, New York, we quickly grew to be the tier 1 supplier to the world's top 10 medical device manufacturers and now employ approximately 200 employees globally. Now, as this map highlights Novanta's global locations, JADAK's locations include the Americas, the Netherlands, China, and a recently new shared Novanta facility called the Novanta Center of Excellence in Munich, Germany. Next slide, please. As far as Novanta, their highly engineered component and subsystem solutions and deep expertise in advanced photonics, vision, and precision motion make them a global technology partner of choice for medical and advanced industrial OEMs. While Novanta provides innovative and enabling solutions in photonics, vision, and precision motion technologies, JADAK falls into the middle vision group, which includes RFID. Next slide, please. As far as ThingMagic, which is a name many of you on the line may be familiar with, ThingMagic is JADAK's RFID product line, and JADAK is a business unit of Novanta. Next slide, please. Now here's my favorite part of the presentation. It's introducing you to our presenter, Dan Ratner. Dan Ratner has worked with ThingMagic products for over 11 years. That's since the company was an independent company. As a product manager at first and of the module product line, then as a project engineer, a sales engineer, and now a principal systems engineer. He's been known to offer wonderful advice on RFID technology, which is brilliant and insightful. So please use today to pick his brain about any questions you may have throughout this presentation or RFID in general. Please hold your questions until the end and type them into the Q&A window located to your right so I can read your questions out loud to Dan once the presentation is over. Please be sure you are typing your questions to me, Justina Valencia, the host. This will ensure your questions are seen and read. At this time, I would like to let everyone know to please mute your lines so Dan can begin his presentation. Dan, take it away.
All right, thanks so much, Justina. All right, so let's start a little bit back up a little before we talk about the RAIN communication interface. And for the benefit of people that aren't working with this day in and day out, what is RAIN? If you've been in the UHF RFID technology field at all, you maybe have heard the words Gen 2, Gen 2 V2, that sort of thing. Well, what's RAIN has done is they've kind of wanted to put an envelope around this and kind of brand it so that it's not just referring to a specification, but really sort of a whole technology group like NFC forum, Wi-Fi, that sort of thing, so they can bring everybody together in an envelope. And as I mentioned, it uses the UHF Gen 2 protocol, and it's been standardized by ISO. Somebody came up with the acronym RAIN for radio frequency identification, and basically, you know, this technology is meant to read and write tags. Of course, you can lock, kill, and do other functions, but basically, it all boils down to reading and writing tags. All right, so what's the current state of how things are without RAIN, we're talking about lots of different ways to talk to readers. So where that causes a problem is, first of all, the language. If you have a different way of communicating with different readers. The other thing is there's consistency and structure that's helpful. For example, if one vendor says, "Oh, I'm going to attach all my settings to each antenna," and somebody else says, "Oh, no, I'm going to do a reader-wide settings," and you know, and so people can, you know, not only have difference in languages, and you know, if everybody looked at the structure the same way, they'd say, "Oh, well, you can just have a one-to-one correspondence of this vendor's command with that vendor's command." But it really doesn't work that way, because once people try to boil this down into how they're going to control things, they can take very different approaches. All right, so what are the features of the RAIN communication interface when the developers went to solve this problem? First of all, they wanted it simple to use and simple to implement. Some people might have worked with the LLRP interface before, that was designed strictly for LAN communications. And it is a fairly complex interface to use and understand. So with this, we wanted it to be a simple serial command interface that then you could use with serial interfaces, or you could encapsulate it like with TCP/IP and then send it over a network. Still a serial interface, but then now you've made it independent of the exact technology used to attach to the reader. The other thing is the developers of RAIN made it, or the RCI, the RAIN Communication Interface, made it very easy to simplify. They created a concept called modes to be able to sort of group settings and to then be able to either communicate a lot or a little. You can just give your reader some rules that it needs to live by and then let it run, or you can control command by command to the reader. So it works both for very low resource, you know, small processors and high resource PCs. And then the other thing they did, which was very clever, is allowed vendors to add their own features. You'll see this in some of our later commands when I talk about how this was implemented on our products. You know, you put an underscore in front of a name, everybody knows it's proprietary. All right, so I'll get into the details later, but what we've done then, what the group has done, they've created what we would call the HTML of RFID. HTML, as you know, is the language that all websites use to communicate with web clients. It's compatible with existing RFID technology, so they didn't try to invent the, you know, go a different way. It's really meant to provide a communication interface for what's there now. And then they looked at what's emerging, like in the IoT world, and people are coming out with communication standards for what they call sensors, and either shared sensors that people will, you know, log into, and the sensor publishes data to whoever subscribes to their service, or more private, you know, encrypted sensors. All right, so let's look a bit at the communication format that's been created here. They settled on a human-readable syntax, which is JSON, and it's supported then by many software tools and libraries. And as I mentioned, we allow it to have vendor-specific extensions. The sources I've used for this presentation are given here. The reader interface supplement that kind of gives the background for the whole RCI work, and then the latest version of the interface guideline here. Now, there's a lot of information in this presentation, and so when you can get a copy. I'm not going to go over every line here, but I hope if you're interested enough, you'll look at you'll get a copy of the presentation, and then you can look at all the details. So JSON, built around a collection of name-value pairs, and the value can be an ordered list. And they don't, in each command, there's no white space, and then curly brackets are used to start and end each message. So here's some examples that I've kind of annotated. So this, and I've color-coded it in blue and red. So blue is what you'd send to the reader, and the red is what you'd get back. So you'd send a command. You can see the name-value pair, command, colon, set config, and then you get back, a report, and it says, okay, I'm replying to your set config, just in case there was some commands buffered, you didn't know which one this refers to, and then it gives an error ID, and an error ID 0 means, hey, everything was good. And then just to show how you start reading, so you start the reading, you get a response right back saying, yep, lovely, I've started. And then after a while, you can get if it sees a tag and it meets your criteria, it's going to give you all the information of the tag. Again, in a similar format, key value pairs, and it can have ordered lists as well. So where you're not giving the, where the placement of the data within the list has meaning, and both sides have agreed to that. All right, some of the terminology may not be that well known in the industry, so let me illustrate it here. One or more antennas in the can then create what's called a read zone. So all the antennas are really looking for a similar population of tags with similar rules. But you can have multiple read zones shown here. One antenna is looking at one read zone and might have its own rules for what kind of tags it's looking for or how it looks for tags. And then the other zone is looking in a different aspect, maybe for a different part of the application. So that's the read zone, and we call it read spots. Is when you see a tag, you've spotted the tag. This is showing then the basic structure then of how all these things go together. You've got your reader configuration that then configures reader level tasks. Then you've got what's called a mode, and we've kind of extended that into workflow. That's a simplification where you can put several different settings into a group, defaults, and just call it by a name. It's very great concept for ease of use. Then below that, you've got the read zone configuration. So these three things together really tells the reader how to locate the tags. You can see to the right then, well, let's go down first. So then below that is the spot profile configuration. Now that tells the reader how to identify the tags of interest and then the actions on the tags found. Now, you can have multiple spot profiles associated with a read zone. If a tag found happens to meet several of the profiles, you've got a priority on the spot profile. So whatever the highest priority spot profile that meets the tag meets, that's the one that's executed. So with those together, then you're sort of then looking at the tags, deciding which are the tags of interest, whether you have to perform any actions on those tags, like read data memory, write to the tag, whatever. And then I've got sort of, okay, then the execution happens. Sort of after that, then you've got these tags in memory, and that's when this thing called a spot report profile comes into play. It tells you then, what do you do with the tag you've got? What kind of information? How are you going to process the information of the tags? And then if you want to go one step further, where instead of just showing things as a hex string, you can actually interpret the data into separate fields that then show you exactly, what's represented in the tag ID or the tag data field. Now, the right here, I'm showing ways that you can kind of read or get started or start these processes essentially. One is trigger. You can use a general purpose input trigger and activate the read zones based on that. You can just do a command, start RZ, and do it there. You can also then, and those kind of then run autonomously and once they get started. But you can also do a command called this tag, which sort of says, okay, I want to just do something right now, and I'm going to activate this spot profile to do something. You know, I've detected maybe one tag in the field, and I just want to stop and do actions on that tag, and that's what the you know, sort of in an interactive mode, and that's what the this tag is meant for. And then you can get various types of reports. You can see when you've gone through this entire list, data interpretation, you can get a report. That's kind of for the tag responses, but you can get other things too. I sort of show from the reader level coming down. You can get heartbeat. You can get error messages that come from the reader and that sort of thing. Things that aren't, you know, that are expected or unexpected, but the reader wants to inform the attached host of those things. All right, so let's look at more into the workflows. The RAIN has the concept of modes, and at this stage, they've kind of made a mode be a group of settings, mostly the over-air settings that would be applied in a read zone. Now, what we've done then is sort of extended that to what we call workflows, but we've tried to map them into, you know, based on the descriptions that RCI said for the modes they've defined. We said, okay, you know, I think we map ours in, so bulk tag reading, we've mapped into the monitor mode. Single tag reading, we've mapped into their HDR mode, and we have then a couple additional tag commissioning and tag update. And what we've done with the blessing of the committee is not only do settings, but also change the behavior of the reader, you know, how it's going to read based on these workflows. So this is our table of you know, what we do for each workflow. I'll just go over a couple. You know, let's just look at the bulk read and single read. They're both reporting at the same 1 tag per second, but the bulk read is, you know, trying to give you all the tags in the field, whereas the single read is meant for the closest tag in the field. It's sort of meant for a desktop reader where you're bringing a tag to the reader, and we're trying to then tell the user about just that tag and not any stray tags, whereas the bulk read, any tag you see is not a stray, we want to know about it. RSSI threshold we've put there so that to get rid of stray tags, mostly for tag commissioning and tag update. Is there a priority in which tag we give? The report time. We've got default read and write powers, but those can be changed. And then we've got the all the Gen 2 over-the-air settings, which again is what RAIN has defined as set for their modes. And I anticipate in the future their modes may expand as well to you know, encompass things that ThingMagic has added to their workflows. All right, so let's look at what we've implemented for our Elara and EL6e readers. This is our new line of desktop and near field readers. They'll read at maximum power. They'll read to about 2 meters, 6 feet. And we've got the board level that we have an RS-232 or a USB interface on, and we've got the reader level, which is USB only. Now, as I'm talking about these settings we allow, I wanted to explain that we have the COM port that's the RCI interface. Well, RCI stands for RAIN Control Interface, so you're going to find me doubling interface a little bit. For your sticklers, I apologize in advance. So the RCI interface is that COM port interface, but then we also have a human interface device interface, which is a keyboard emulator. And both of those are operating at the same time. So you'll tell the reader what to do through the RCI interface, and then you can control the human interface and tell it exactly how you want that information presented. All right, so I've kind of lumped these features. Some of them are a bit in different levels as far as the RAIN communication interface has defined them, but I'm sort of lumped this as then sort of functional things. So let's look at reader maintenance, and I'm not really going to go through the sample commands to the right. When you get the presentation, you can look at those and sort of parse it. But what I want to convey here is what we're capable of doing in version 1 of the firmware that we've released with Elara and EL6e. So we can update the firmware through this activate update mode, and there's a lot of commands behind that to transfer the firmware and that sort of thing, which I haven't shown here. You can reboot the reader. You can get the reader information. So this is information about the reader. You can set the time so that with the timestamps that you have on the tag, you can show the actual time and not like a relative time since boot. You can get the time as well to see whether the time's been set and that sort of thing. And then you can enable heartbeat reporting. So this is where if you're getting no tags at all and you wonder whether the reader's still working, you want to kind of get this heartbeat message going, and you can control how often it is. So you can do it once a second, once every 10 seconds, whatever. So you know that the reader's up and running, so you don't just get radio silence and not realize that somebody's kicked the power cord. All right, configuration maintenance. We allow, you can get all the settings, find out what your current settings are. You can save these settings to memory. You can restore the settings from memory, and then you can restore defaults, bring the reader back to factory defaults. All right, I/O control. We have a beeper on the boards, so you can control the volume of the beeper. You can send a command to make it beep now, and you can see some of these have not been considered by the RCI committee yet. So we've got an underscore under the command to beep because that was something that we couldn't quite map into something that's existing in the standard now. You can get GPIO values and set the GPO values as well as I/O control. The Elara reader just has a USB cable, so there's no access to the GPIO ports there. But the board itself, if you get the board with 13 pins, it's not only got the same USB interface, but it's got the GPIO inputs and outputs as well. Then we've got our human interface device controls. You can enable or disable it. You can just show the EPC of the tags through that interface. You can show the EPC and metadata. Metadata is conditions of the read. What frequency did you read it at? What level did you read it at? That sort of thing. And then you can either show it just in sort of separated format, or you can actually show it in the RCI format so that you actually get the curly brackets and everything else, kind of the same way it would output to the COM port, it's going to output to the human interface. All right, and so now we're getting into the read control settings. You got to set a region of operation. You got to set, well, you have to set the mode because that sets a lot of parameters. Some of which we let you also set asynchronously, but some of which you really, currently it's the only way to set through the workflow. You can set the read power. We have a different power for writing because often tags need a little bit more power to write than they need for read. And if you start reading at the higher power, then maybe you'll start reading stray tags. So what you can do is you can read at a lower level and then singulate the tag and write at a higher level. And then there's the start reading command to start immediately. Start RZ for start read zone. All right, the actions to perform on the tags found. This is part of the spot profile. So here's some examples. Read tag memory, write to and lock a tag, read from memory. It looks like I've duplicated that. I'll be darned. And then you can also just, as I mentioned, this tag you can you can read execute a spot profile immediately. So that's the command this tag profile 1. Then how to control what metadata you report with the tags. We've got the standard report fields that the RCI committee has come up with, and then we have additional ones that ThingMagic supports, such as what Gen 2 parameters were you using when you read this tag, that sort of thing. All right, and so let's look at what we're likely to see in enhancements in release 2 to kind of, bring us up to the full functionality. This is, we've kind of made the Elara, it's a single antenna device. We're trying to make it, we're really concentrating on ease of use, and we're really listening to what customers need for this product. So we put together sort of the simple 4 workflows that we felt were necessary, and now we're bringing the product out and asking people what they need. And here's things that we've gotten in feedback, and we're very interested in hearing from you too. So additional control over the underlying workflow settings. We've got the power. People want to maybe set the session control, maybe even set the reporting time, that sort of thing. So we're looking at what, just trying to decide then what would spawn a new workflow versus what do we want to have for an option on top of the workflow we've got. Selecting the tags over the air, so you're just looking at a subset of tags. We just added ASCII interpretation of the EPC data. So if you actually write in an EPC, an actual name of what you're looking at, we can display it that way as well. Report of the reporting cadence. We had a customer come to us and say, okay, we love your product, but this is what we want. If you bring a tag to this, we only want you to report that tag every 3 seconds. But if you take that tag away for a fraction of a second, we want you to be ready to read a new tag right away. So we've added this cadence control. We can actually demonstrate that now. And this was something, even though the RCA protocol does have the concept of when and how you report the tags, this was sort of unique enough that didn't quite map to what's in the standard now. So we made this these 2 settings be proprietary. Continuous reading and duty cycle control. Right now we read every second for a portion of that second, and people will want continuous reading. We're going to be adding that. Read triggering on the GPIO. We didn't put it in first round because the readers don't have the GPIO exposed, but we know that that's something that people are going to want. Right now, the RS-232 interface is data in, data out. We know people are going to want the connection detection and flow control and that sort of thing. Again, that's the board level product only. Multiple data fields returned with a read. Right now, our modules on which this is based can automatically return any data field with the EPC. And then if you need more data fields, you got to kind of singulate the tag, a little bit more complicated. So we kind of push that off into the second release. And then the other thing, tag updates. And I didn't really explain that workflow really well. So the two that I didn't really mention was tag commissioning. That's meant for commissioning the EPC of the tag. So you get it from the factory and you want to give it its identity. Tag update really works for the user memory. So what would you want to do if a tag goes by the reader? Well, you might want to timestamp the tag. You might want to put the name of the reader that it passed by. So those two are supported today. You also might want to increment a counter so you know how many times this tag has gone by. That is something we sort of pushed off to release 2. So as I say, the first few of these things we've already got sample code for. These others we're kind of prioritizing among other things, and we want to hear from you. As you're using our Elara readers, we want to hear what's important to you, and we'll prioritize those as well. And actually, we want to hear from you if you want a totally different workflow as well. This is meant to be customizable for specific customers. All right, so what tools do we provide to help you out? We have what's called the ThingMagic configuration tool. This is based on a tool. If you're familiar with our products, we call this the autonomous configuration tool, which would put settings into our modules that then could be saved and run automatically on a GPIO line being brought up or the power being brought up to the module. And so this is so similar to what we wanted to do with the Elara and the EL6e. We've extended this tool then, so it recognizes which kind of printer what kind of reader that it's connected to, and then it will automatically give you the screens that are relevant for that. And so you can configure using this, you can update the firmware using this, and we also have a results screen that you can either see the results on the COM interface, or you can actually see the human interface device output. So it just sort of puts up like a notepad, and you'll see it as if it's, the reader looks as if it's typing the information when the output's in the HID interface. We also give you, in an SDK, code samples in Java to set up bulk tag reading, single tag reading, tag commissioning, tag update, and firmware update. As I say, there's a lot of commands involved in firmware update, and you can just grab this code and use it in yours. And we've also got an app I'm kind of giving a little commercial for. We're just in the process of productizing this. This was a tool just one of our developers decided that for their own benefit, they wrote this in Python, and it just has a whole list of rain commands to the left that just get imported from a text file. So if you want to put your own commands in there, your own values, whatever, they just get imported, and then just by pressing on the buttons, it sends the command. You've got a little window, you can create your own commands and edit, and I've just found it very useful as I'm going through this and testing different things. So right now, to get this, you'll have to talk to our support group. We're in the process of sort of bundling it up, and I'm hoping at some point then we'll have this as part of the SDK as well. Again, it's a Windows application. All right, I'm poised for questions now.
Thank you, Dan. All right, one of the questions that came in is asking, is RCI interface applicable to UHF handheld reader use?
Yes, it is. As I say, there's sort of two ways that you can look at this. You can either have RCI. Well, first of all, handheld readers usually have some sort of a processor in there that then has to talk to some kind of an RFID device. So it's very possible you'd have a module inside that would communicate with the with RCI. The other thing is, you could use this as a sort of a configuration tool. Say it's just a dumb handheld reader that goes Bluetooth back to your back to something. You want to kind of pre-configure and save it. You could use the RCI then to program this and save it and then use it, much like we've kind of implemented for the Elara product.
I would just like to reiterate to everyone on the line that if you do have any questions, now is your time to pick Dan's brain. Make sure you're typing your questions to the Q&A window directed to me, the host, Justina. This will ensure your questions are seen and read. Dan, another question we had is, so basically the Mercury API is just HTML hosted now. What model readers does this range structure work on? And is there a way to upload tag read info directly to AWS databases like Aurora?
All right, so our API is somewhat independent. Let me show you something I put together kind of for my benefit. When I was trying to learn about this, this is sort of the full, RCI that all the different commands, the different things that you can do, and I kind of mapped it then to okay, what does it look like for the ThingMagic API? And so right now you'd use these rain commands for the Elara and EL6e. You'd use our API then still for our other products. And over time we've got to make a decision then. Do we bring rain forward to those products or not? As far as the database is concerned, now I'm not that familiar with this, but the JSON format is very simple and very parsable. So you could use it that way, and you could also use a RAIN reader. There's nothing that says it couldn't have, just like we had a separate HID interface. If absolutely you could, you want to stream it in some different way, there's nothing to say you can't use RCI to control the reader, but then have the output be in a different format to a database.
Okay, this next question is, any C hashtag demo code? Question mark. Any C number demo code?
Right now, our demo code is just in Java, so that's what we have to offer. But as I say, this is very text based, so I think translating it to other languages is not going to be difficult.
Okay. We have a lot of questions coming in, so I'm just trying to document them all. Next question is, how can we get access to the SDK and software demos? Are they available on the Impinj support site?
Not on the Impinj support site. They should be on our website right now, and we can point out where that is. If for some reason you can't find it, contact our support people, and they'll show you where it is. But it's a little zip file. It's got the Java examples. It's got the ThingMagic configuration tool installer, and it's got the very latest firmware. So we put out with every release of the firmware, we put out a new SDK.
Okay. The next question is, to use RCI with a handheld reader, do I need to develop a special interface other than the STD SDK provided by reader manufacturer?
So again, this is a serial string interface, and so you can think of it as sort of somewhat doing away with the API. What they've tried to do is sort of make the minimum level of commands you have to send, and then you simply have to open some sort of a serial link to this device. And as I say, it can be Bluetooth, it can be USB, it can be RS-232, whatever you have that can and it can be TCP/IP if you've got a LAN connection. Whatever it takes to get a serial two-way communication going, that's what you use to set up to set up RCI.
Okay. The next question is, thank you for your response. Is that Python module that uploads .txt files that will be coming out a wrapper for the SDK in C number?
In C#, is that so? Yeah, we haven't really offered the source code to that. Right now, it's an executable. So yeah, we'll maybe think about how far we want to go with that. With making the RAIN demo something that's available and extendable and whatever. Right now, it's just something that, as I say, our developer put together, and I found it very useful, and I think you will too.
I think everybody's really taking you up on that picking your brain offer I mentioned at the beginning.
There's not much left. You got to share.
Another question is, does RCI replace the Mercury API?
In a sense, we're considering, because the Mercury API works across all our products, we're considering whether people will find it very useful to then. Well, let me back up. What's cool about the Mercury API is it knows how to talk to our full suite of products that have very different interfaces. The full-size readers with a Linux processor, they talk LLRP. The modules all talk our proprietary serial protocol, and we've made all that level transparent to the API calls. And right now we're on the fence. Is the RCI just so dead simple? People are going to say, "Look, I don't want to go to your API to talk RAIN," or are they going to say, "Hey, we've got all these applications written to your API. We really want you to support RAIN over your API." So that's something we're looking for feedback on. Is that something that people would find valuable for us to do?
Okay. And I believe we have one last question. So still, if everyone has any other questions, please feel free to type them to the host. Well, the other question is, what is the difference between RCI and LLRP?
There's very similar structural things. A lot of the names are changed. They've got RO specs and AI specs and that sort of thing. I think the language is, I have to be honest, I haven't looked at LLRP in a while. I think the language is more of a database language, and it's really not meant for a serial protocol. So it's I'd say it's a little bit more, it's more complex to use, and the language structures are more complex. And so I think it's still out there. It's still a standard, but I think a lot of the people that got together to come up with the RCI were saying, look, what are developers telling us for why they haven't implemented LLRP? A lot of people did, but a lot of vendors didn't. So they were saying, okay, let's look at why. And a lot of it was that you needed a lot of intelligence on the host side to send commands and stuff through LLRP, whereas they wanted to really simplify it with these serial commands that were easy to create, so you could have just little tiny processors being able to do the RAIN control protocol.
Very well. I do believe that you've answered all of the questions. So if I can have the next slide, I do have a few slides that will conclude our presentation. Our upcoming events. If you would like to see any, if you're interested in seeing any of our capabilities live, you will have a couple of opportunities to do so. We will be at the Embedded Vision Summit in California in May. That is a machine vision show, so RFID doesn't really apply at that show. However, in June, we'll be at the RAIN Alliance Group meeting in Florence, Italy. In August, we will be back in the Anaheim region for our biggest trade show, which is the AACC, and RFID will be a big portion of that show. And then lastly, we'll finish off the year co-exhibiting with one of our sisters companies at the Medica show in Dusseldorf, and the details on that are still forthcoming. Can I have the next slide, please? Um, what I would like to mention is this is very important to any European people on the phone, uh, in alignment with the recent GDPR. If you are not currently our customer, and are new to us, we are unable, unfortunately, to send you a recording of this webinar, but that does not mean you cannot get it. So if you would like to receive a recording of today's presentation, please email us at opt-in at jadaktech.com, indicating we have your permission to send you marketing information. This is the only way that we will be able to actually send you a recording of this webinar. However, you can visit our website under the resources section under webinars. By April 26th, we will have this webinar posted to our website. So if you are not comfortable with receiving marketing information from us, you can check back on our site and we will have a recording of today's session posted to the website. So please make sure you do that. And then I believe our last slide. So at this time, I would just like to thank everybody for joining us today, and a big thank you to Dan for his time and presentation. As I mentioned, a recording of this session will be available up on our website within the next week, and it will be mailed to all of our registrants, excluding the European countries. If anybody has any more questions on RFID or any of our other technologies, we do invite you to visit our website at jadaktech.com or schedule a tech day with us by emailing us at techday@jadaktech.com for a free technology consultation. At this time, thank you everyone for attending and have a great day.